The goal of this video is to give you some visuals to understand how to balance chemical equations. So I'll go through the first steps a little bit quickly, but the first step to balancing a chemical equation is to make sure that you have the proper salt formulas for each salt that is in the chemical reaction. So my chemical reaction is aluminum sulfate reacting with silver chloride to make silver sulfate and aluminum chloride. So the first thing we'll need to do is write the salt formulas. So I have done that here. First with some bubble pictures. Doing the bubble pictures for each salt individually, make sure that I get the right salt formula. So when you're doing this, do the bubble pictures first so that you make sure your salt formulas are correct. And you'll see here that I've got sulfate in blue, and there's 3 of them for every 2 aluminums. And silver, it's a 1-to-1, but silver sulfate is a 2-to-1 ratio, and aluminum chloride is a 1-to-3 ratio. And you can see that the salt formula is not dependent upon how many of the atoms appeared in the reaction side. They all have to be made independently. So my formula looks like this. Aluminum 2 with 3 sulfates, 1 silver, 1 chloride. 2 silvers, 1 sulfate, 2 silvers, 1 sulfate, and 1 aluminum and 3 chlorides. So I have those as blocks corresponding to the color that they are. So aluminum's green, and I have a green here. I've got my silver chloride, my silver sulfate, and I have my aluminum chloride. The goal of balancing is to make sure that all of the atoms that we started with on the reactant side are accounted for on the product side, because matter cannot be created nor destroyed. So all of the atoms we have over here, they can't just disappear, they have to be accounted for in the product side. So we can see that there are some problems already. For instance, on the reactant side, I only have 1 silver, 1 pink one, but over here I have 2. And I only have 1 chlorine here, but over here I have 3. My aluminums are off, and my sulfates are off. So nothing is balanced so far. So now we need to figure out how to make the 2 sides the same. I'm going to start with aluminum. That's over here. I have 2 aluminums, 2 over here, which means I need to have 2 aluminums on the product side, because if 2 aluminums go into the reaction, 2 aluminums must come out of the reaction. I am not able to just add an aluminum in. It comes in the form of aluminum chloride. So if I want to add 1 more aluminum, I have to add an entire aluminum chloride molecule. I have to add an entire aluminum chloride compound. So this whole thing has to come with it. So now my aluminums are taken care of. I've got 2 here. I've got 2 green ones over here. Those are good. Next, I'll do my sulfates. So I've got 3 sulfates over here, but I only have 1 here. So that means I need 2 more of this silver sulfate molecule to get me 3. So I've got 1. So I've got 2 and 3 now, and 1 more. That gets us 3, and I have 3 over here. The last one that I need to balance is my silver chloride. On my product side, I've got 1, 2, 3, 4, 5, 6 silver molecules, 6 silver ions, but on my reactant side, I only have 1. And same for chlorine. I've got 1, 2, 3, 4, 5, 6 chloride ions, but only 1 over here. So that means I need 6 total silver chloride. So I've got 1, 2, 3, 4, 5, and 6. And so now it looks like everything is balanced and I can fill in the numbers. To show on a chemical reaction that we have more than 1 compound or molecule, we do a coefficient in front of the salt. A coefficient in front of the salt says that I have a certain amount of the whole salt that comes after it. Whereas the subscripts only tell you that you have a different amount of the ion that comes before it. So this 2 here with aluminum says that I have 2 aluminums, 1, 2. And this 3 here says that I have 3 sulfates, 1, 2, 3. So for my silver chloride, I have 1, 2, 3, 4, 5, 6. So that means I need to put a 6 in front of it here. I only have 1 aluminum sulfate compound here. So this can be left blank, but really it's like there's a 1 there. You just don't have to write the 1. Let's do silver sulfate now. I've got 1, 2, 3, so I put a 3 in front. And lastly, aluminum chloride, I have 2, so I put a 2 in front. And so this coefficient, it tells me that I have 6 of the entire thing. So let's say, for instance, I want to figure out how many of an ion I have if I just see the coefficient in the salt formula. Well, I've got 2 of this aluminum chloride, like so, which means 2 times 3 is 6 chlorines. 1, 2, 3, 4, 5, 6. And that works for any of them. So this was a visual representation of balancing chemical equations.